This is our second exam block, and we're going to be covering several things in this lecture. The first, the objectives of this lecture are going to be to cover the big picture of where we are right now in the overall context of the course. The second is we are going to look at second order circuits, the topic of this second exam block. And then we're going to zoom into the specific skill about second order circuits that we'll be learning in this lecture, which is initial conditions. So let's begin by talking about what this big picture is. Let's begin by taking a holistic view of the entire course. We began by looking at circuits with a single inductor or capacitor and 0 resistors. And that was back in that very first exam block. And there, if we had a single inductor or capacitor and no resistors, in other words, we're talking about circuits that look maybe like this. And given I, you're asked to find, say, V. Your only techniques were integration or differentiation. And in particular, it was I equals C dV prime, V equals L I prime. And of course, this is the current through the capacitor, voltage across the capacitor, or voltage across the inductor, and current through the inductor. Or you could just as well solve these things for, integrate both sides inside for the remaining variable. So if it was that, the voltage across that capacitor is equal to 1 over C times the integral from T naught to T of the current through it plus your initial condition. And you could do the same trick to find the current through an inductor at any point in time. The two equations look remarkably similar. These are our methods for that very first exam block. And then after we covered those, the next step that we did was to cover what we call first order problems. And that's when you have one inductor or capacitor, and you've got exactly one resistor, or perhaps a series of resistors that can be simplified down to one. And we're looking at the DC stepped response. In other words, what happens to the circuit when you expose it to one DC value for time less than 0 and a different DC value for time greater than 0. So perhaps the prototypic circuit there might look something like this. And you want to find that VC, or maybe I, or whatever else. You could find anything from this circuit. And to do that, we use the plug and chug equation of V of infinity plus V naught minus V of infinity times e to the minus t over tau, or the equivalent one for current through the inductor. And we always had to find that current through the inductor or the voltage across the capacitor first. And then after finding VC or IL, depending upon what was given in the circuit, then and only then would you find what you're actually asked to find. Now that's different than what we're going to be doing now. So all this over here is test 1. So for test, which took us 3 weeks to cover. Now for test 2, we're going to be in the world of second order circuits. So for that, we're going to have exactly 1 R, 1 capacitor, and 1 inductor. And again, we're going to be looking at DC stepped response, and by stepped response as opposed to step response. A step response is the response to a U of T. A stepped response is the response to 2 different DC values, just like we did for first order. So again, that prototypic circuit might look something like this. As an example, you've got a resistor, and you've got a capacitor, and you've got an inductor in there. And now You need to find some aspect of what's going on. Maybe, for instance, the current that's flowing around here. Okay. As we walk through this material, we will start off by describing how initial conditions work for second order circuits. Not the same as first order. Then, just like we did with first order, we're going to cover sourceless, source-free circuits. In other words, we'll cover a circuit that has some sort of initial condition, perhaps the capacitor is charged, the inductor starts off with a magnetic field, so there's current going through it, and then we'll see how it spins down. And then after describing how that works, we'll describe how it works with step responses, where you start off with an uncharged circuit, you give it a DC input, and you see how it grows towards infinity. And then we'll combine all those things using plug and chug equations. Unlike first order, now there's going to be 3 totally different plug and chug equations for second order. So this is our approach for second order. And this also will take 3 weeks. So the fact that this takes just as long for what appears to be shorter means that these steps are more complicated. In fact, we're going to be speeding up considerably in our second order section from the rate of material that we covered in the first order. And then last exam block, we'll be doing any order circuit. So now we can have lots of resistors, capacitors, and inductors. And instead of DC sources, we'll now have sinusoid sources. And you might think that that makes the problems far more difficult on both sides. Here's sort of that prototypic thing. We've now got, say, a cosine of t, and now we've got maybe a few resistors here, but we've also got capacitors, maybe with more resistors, and maybe a resistor here with a inductor. And you want to find maybe this current going down here. And the amazing thing is that it's actually a whole lot easier, because we're going to use a different approach entirely. We're going to use phasors for this. Phasors are magic. They make the entire circuit reduce down to the equivalent of just a plain old DC circuit. This will also take 3 weeks. And then we'll have the mishmash of topics we'll cover after test 3, which will be also on the final exam. The final exam will be comprehensive with everything. We'll be covering primarily power circuits and multi-phase circuits. So now that we've talked about the big picture, let's zoom in and talk about second order circuits in general.